Okay, so you're prepping for like senior software engineer interviews. You know, the ones where they really dig into architecture?
Yeah, those can be pretty intense.
And you're probably staring down this mountain of concepts, right? Well, today we are going to try to be your guide, your Sherpa,
That's a good analogy. It can feel like climbing Everest sometimes.
right? And we're focusing specifically on microservices.
Mm,
Think of this as your distilled guide, like the essential stuff about architecture that can really help you stand out in an interview.
exactly. And not just for like answering those system design questions they throw at you, but also for demonstrating you really understand how to build these systems that can actually like scale and handle real world use.
Yeah, so we're going to draw on some core principles here, stuff that applies to a bunch of different interview scenarios.
Oh.
So let's jump right in. And you know what? It makes sense to start with something that sounds super basic, but is actually surprisingly hard to pull off in the real world: independent deployability.
Yeah, for sure.
Being able to make a change to a single microservice, deploy it, release it, all without impacting anything else in the system.
It sounds so simple when you put it like that.
Right.
But honestly, getting to that point where you have true independent deployability, that's where the rubber meets the road with microservices. And honestly, the struggles teams go through to get there, it actually forces them to adopt a lot of other good practices.
Which brings us right to loose coupling.
Absolutely.
You can't really have independent deployments if all your services are tangled up.
Right. No.
If making a change in one service means you got to redeploy like 5 others, you haven't really achieved what you set out to do.
Exactly. And that's why having good contracts between your services, clear, well-defined, and stable contracts is so important.
Okay, so those APIs are basically like public agreements.
Yeah, think of it that way.
And if those agreements are changing all the time, you're constantly rebuilding the bridge between your services. And that just kills any chance of them being independent.
Yeah. You said that certain implementation choices can really get in the way of this, and I think we called out shared databases as a big one.
Shared databases, yeah.
Yeah.
Can you give us an idea of why those can be such a pain when you're trying to build microservices that can be deployed independently?
So what's interesting, and I think a lot of people miss this early on, is how a shared database, which seems so convenient at first, can create all these hidden dependencies. Imagine you've got a bunch of microservices all hitting the same database tables, reading and writing data. Now let's say you need to make a change to the database schema.
Just a little tweak.
Right, maybe for a new feature in one of your services, but that seemingly small change could have huge unintended consequences for all the other services that rely on that same schema. And boom, suddenly your supposedly independent deployment becomes this huge coordinated event.
And then everybody's stressed out.
Oh yeah, I've seen this happen where a small team's deployment took down a critical service owned by a completely different team, all because of an unexpected database dependency.
Okay, so imagine you're in an interview and they start asking about maintaining stable APIs and contracts. What are some specific strategies you could talk about to show them you understand these potential problems and how to avoid them?
That's a great question. First off, you want to talk about API versioning. Having clear, distinct versions of your API so people using them aren't forced to upgrade immediately every time you make a change.
Like you give them some breathing room?
Exactly. And you want to emphasize the importance of backwards compatibility whenever you can. Mention things like data transfer objects, which can really help to create a clear separation between services. And if you really want to impress them, bring up contract testing. It shows you're thinking proactively about how to keep those contracts stable and make sure changes in one place don't break things somewhere else.
That makes a lot of sense. So let's shift gears a bit and talk about how we actually decide where to draw the lines between our microservices. We've been talking about modeling around a business domain. Can you explain what that really means in a practical sense for somebody who's aiming for a senior role?
So if you take a step back and look at the big picture, this is really about applying those domain-driven design principles, but at the architecture level, not just inside a single code base.
Well, it's like zooming out a bit.
Yeah, exactly. The main idea is to align your microservice boundaries with different parts of your business, like self-contained areas. Instead of splitting your architecture based on technical layers, like a UI service, a business logic service, a data service, you organize things around business capabilities.
I see. So give us an example.
So you might have a dedicated service for like customer onboarding, another for order fulfillment, another for your product catalog. You get the idea.
Okay, I'm following you. So for someone who's used to working with those more traditional layered architectures, how does this domain-centric approach, actually make it easier to roll out new features for the business.
What's really powerful here is that when you need to add something new or improve an existing business capability, the changes you need to make are much more likely to be contained within a single business domain.
So they're more isolated.
Right. And that means they'll be limited to a smaller number of microservices. Ideally, just one.
That's the dream.
Yeah. Remember that Music Corp example we talked about with the three-tiered architecture? If you wanted to add something as simple as a favorite music genre feature, you probably had to make changes to the front end, the back end, and the database schema. And that meant coordinating across a bunch of different teams and deployments.
So a tiny little feature could turn into this massive risky release.
Yeah, exactly. But if you focus on keeping each microservice really focused on a specific business function, you significantly reduce the impact of any change. It's like saying, this specific piece of business value, this is where it lives, all the code and data it needs are right here within this boundary.
So it's self-contained.
Yeah. And that makes it so much easier for individual teams to own and iterate on their specific parts of the business.
That makes sense. So what if an interviewer asks you something like, how would you go about breaking up a monolithic application into microservices? Or how would you design a new system from scratch using this domain-driven approach? What should you be thinking about?
In that situation, you want to talk about how you'd figure out the core business domains, whether it's from an existing application or from the business you're trying to model.
Okay, so you'd start with the business itself.
Right. You'd think about the key entities, the processes, the rules that really define how the business works. And then you talk about how you draw boundaries around those domains, aiming for services that make sense from a business perspective and are as independent as possible from each other. It's about finding natural dividing lines in the business where you can create these self-governing units of functionality.
Okay, I like that, self-governing. So we've covered independent deployability, the importance of loose coupling, and this whole idea of designing services around business domains. Now let's dive into the concept of microservices owning their own state and why avoiding shared databases is so crucial in this model.
So this is like a non-negotiable rule if you want true independence. Each microservice needs to be the sole owner of its own data. It manages its own data. If another service needs information that it manages, it should have to go through the proper channels.
Like making a formal request.
Yeah, it should request that data through a well-defined API instead of just reaching directly into the other service's database.
So no backdoors. What are the real advantages of this owning your own state idea?
The really awesome thing here is the level of autonomy it gives each microservice. They get to control their own data model, their storage, how they share that data with the outside world. It's all up to them. And that encapsulation is super important for limiting the impact of changes. It's kind of like the information hiding principle in object-oriented design. The internal structure of a service's data becomes an implementation detail. Other services don't need to know about it, and they shouldn't be directly dependent on it. This significantly reduces the risk of those breaking changes rippling through your system.
So to really drive this point home, if you're in an interview and they ask about shared databases in a microservices architecture where you're trying to have independent deployability, your answer should basically be avoid them at all costs.
Pretty much, yeah. There might be some very specific rare edge cases where you can't avoid some level of shared database access.
So like never say never.
Right, but you have to approach it super carefully, understanding the trade-offs you're making. In the vast majority of cases, the benefits of data encapsulation, especially when it comes to independent development and deployment, far outweigh any perceived convenience of a shared database. And absolutely, if you're talking about data management in a microservices world during an interview, you want to emphasize this principle of services owning their own data. It's key.
Okay, so let's tackle the question that seems to come up all the time in the microservices world. How micro should a microservice actually be? The name itself implies a certain scale.
Right. It's a natural question, but getting hung up on a specific size, like lines of code, is usually not helpful. Different programming languages are so different in how expressive they are, so what might be a concise piece of logic in one language could be way more verbose in another. Trying to enforce an arbitrary size limit just doesn't work well in practice.
I remember reading a quote that said, "A microservice should be as big as my head." What's the idea behind that?
So the essence of that quote is about cognitive load, how much the team can realistically understand. A microservice should be something that the team responsible for it can easily grasp. They should understand its purpose, its dependencies, its data model. Of course, what fits in that mental headspace will vary depending on the team's experience and how familiar they are with the domain and the technology.
Right, there's no one size fits all.
Yeah.
Another perspective we came across was this idea of having as small an interface as possible. How does that relate to this whole size thing?
That goes right back to the principle of information hiding that we talked about earlier. When you aim for a minimal and well-defined API, you're reducing the surface area of interaction with other services. It doesn't really matter how complex or how many lines of code are inside that service. What matters is the external contract and minimizing dependencies on those internal details. A small, focused interface automatically makes a service easier to understand and less likely to be affected by changes in other services.
So instead of worrying about lines of code or some other abstract metric, what should teams be focusing on when it comes to the size of their microservices, especially when they're just starting out with this approach?
The most important things to think about early on are how many independently deployable units your team can actually handle and how well you've defined the boundaries between them to minimize coupling. Remember, the more services you have, the more complex your system becomes to operate. So it's often a good idea to start with a smaller number of well-defined services and then iterate from there. Getting too caught up in making each service as tiny as possible can sometimes add unnecessary complexity and overhead. Showing that you understand these real-world trade-offs is a key point to get across in an interview.
Absolutely. So another big advantage people talk about with microservices is the increased flexibility they provide. There was even a quote that said, "Microservices buy you options." Can you break down what kind of flexibility we're talking about here for someone who's considering using this architecture?
That quote really captures a core benefit. Microservices can give you organizational flexibility because different teams can work more autonomously and choose the technologies that are best for their particular service. You get technical flexibility, which makes it easier to adopt new languages, frameworks, or databases for individual services without disrupting the whole system. There's also flexibility in scaling. You can scale individual services based on their specific needs instead of scaling the whole application. And finally, they can make your system more robust. If one service fails, it's less likely to bring down the entire system.
But I'm guessing this flexibility comes with its own set of costs and complexities, right?
Yeah.
Like anything else. What are some of the key trade-offs that someone thinking about using microservices should be aware of?
For sure. That increased flexibility comes with increased operational overhead. Now you have multiple independent services that you need to deploy, monitor, and manage. Communication between those services introduces its own set of challenges, like dealing with network latency, making sure you have good error handling, and setting up distributed tracing. Testing also becomes more complex because you need to think about how different services interact. It's definitely not a silver bullet. That's why this idea of an incremental approach, like turning a dial to slowly increase your use of microservices, makes a lot of sense. You can manage the growing complexity as you get more comfortable with microservices. In an interview setting, showing that you're aware of these trade-offs is really valuable.
That's a good point. So last but not least, let's talk about the connection between architecture and organizational structure, the thing that Conway's law is all about. We look at Music Corp and their three-tiered architecture, which mirrored their team structure. Can you walk us through how that demonstrates this principle?
The Music Corp scenario is a classic example. They had this architecture with separate UI, back-end, and database layers, and it matched their organizational silos perfectly. They had separate teams responsible for each technical layer, a front-end team, a back-end development team, and a database admin team. Because of that, even a seemingly small feature like adding a favorite music genre required a chain of work and coordination across all three of those teams and their deployments.
So they were kind of stuck in that waterfall model because of how they were structured.
Exactly. And the key takeaway from Conway's law is that the way you organize your teams will inevitably shape the architecture of the systems they build.
It's like the system ends up reflecting the organization.
Yeah, precisely. Conway's law basically says that organizations that design systems are constrained to produce designs that copy their communication structures. The three-tiered architecture that we see everywhere isn't necessarily bad, but it's often a direct result of organizing teams around technical specialties instead of around streams of business value.
Okay, so what kind of organizational structure would be better for a microservices architecture that's aligned with business domains, like we talked about earlier?
The idea is to structure your teams around business capabilities or value streams. These are often called stream-aligned teams. Each team takes full responsibility for delivering a specific piece of business value. So in that Music Corp example, instead of having teams based on technology, you might have a customer engagement team that's responsible for everything related to how customers interact with the platform. They might own a piece of the UI, the necessary back-end logic, and the data that goes with it.
So they own the whole vertical slice.
Right. And how does this kind of team structure support a microservices approach? Well, because the team is focused on a particular business domain, the microservices they build and run will naturally align with that domain too. A single microservice might contain a thin vertical slice of those traditional layers, a bit of UI, some application logic, and its own data storage. And that's all owned and maintained by that one cross-functional team. This really increases the cohesion of business functionality within the service and aligns perfectly with the team's responsibilities. It makes it much easier and faster for them to deliver value independently within their domain. This concept of a streamlined team from team topologies highlights a team's ability to deliver customer value on their own. Understanding how organizational structure and software architecture fit together is a sophisticated point that interviewers will appreciate.
It shows you're thinking beyond just the code. So to wrap things up, we've covered some of the most crucial architectural considerations for senior software engineers, especially when it comes to microservices. We talked about how important independent deployability is, the need for loose coupling through stable contracts, the benefits of modeling our services around business domains and making sure they own their own state. We also explored the tricky concept of microservice size, the flexibility that microservices can provide, and how team structure and system design are intertwined, which is what Conway's law is all about.
Mastering these principles gives you a really solid foundation, not just for answering those tough interview questions, but also for approaching system design in a more strategic and informed way.
I totally agree. So as you keep preparing for those interviews, really think about how these concepts relate to your own experiences and the systems you've worked with.
And here's something to think about as you go. Think of a complex system you've worked on. What was the biggest thing that prevented you from achieving true independent deployability? What fundamental changes in architecture, team organization, or development processes would you have needed to overcome that challenge?
Or might still need.
Or might still need, exactly. Food for thought.
Definitely. Thanks for diving deep with us.
It's been a pleasure.
And to all you listeners out there, best of luck with those interviews. You got this.